section, I'll be discussing Le Chatelier's principle. Now this is Le Chatelier, Henry Louis Le Chatelier, and he was born in 1850 and lived till 1936, and he was a very influential French chemist of the late 19th and early 20th centuries. Now he was most famous for devising Le Chatelier's principle, used by chemists to predict the effect that changing conditions have on systems in chemical equilibrium. So his principle is all about equilibrium. And his principle can be summarised with this box here. If a chemical system at equilibrium, and you'll need to remember that the symbol for equilibrium is two arrows, one going each way. If a chemical system at equilibrium experiences a change in concentration, temperature, volume, or partial pressure, then the equilibrium will shift to counteract the imposed change, and a new equilibrium will be established. So that's what Le Chatelier is most famous for. Now for this lesson, I'll be discussing the classification of oxides. Now most elements in the periodic table will undergo bonding with oxygen to form oxides, and so there'll be different types of oxides. So you'll have metallic oxides, non-metallic oxides, and semi-metal oxides, and they have different properties. So let's start by looking at metallic oxides. As you can see in the picture, that's an example of a few different metal oxides, and they're all very pretty colours. So metals will produce different coloured oxides. Now most of the oxides of metals are bases. Okay? If they're soluble in water, for example the group 1 oxides, including sodium and potassium, also calcium oxide and barium oxide, they'll form alkaline solutions, which is basic solutions. Now, some insoluble oxides, some examples: magnesium oxide, copper oxide, iron oxide, and silver oxide. So they don't dissolve in water. Now, they can be neutralised by strong acids to form salts and water, so it becomes an acid-base reaction to form a salt and water. Because some common basic oxides include sodium oxide, magnesium oxide, calcium oxide, iron oxide, and copper oxide. Soluble basic oxides react with water to form alkaline solutions, okay? So they'll form basic solutions when you add water. And here's an example. Calcium oxide as a solid will dissolve in water to produce calcium hydroxide, which is a base, in aqueous solution. Alkaline solutions contain hydroxide ions. So whenever you see OH-, which is a hydroxide ion, always think that's going to be basic. So red litmus will turn purple or blue in these solutions. All group 1 oxides are soluble in water. So sodium, potassium, all of group 1 will dissolve in water. And group 1 is also very reactive. So we've got an example here. Potassium oxide dissolving in water to produce potassium ions and hydroxide ions. Okay? Both aqueous, which means they've dissolved in the water. Now looking at the non-metallic oxides. Non-metallic oxides are often acidic, but some of them are actually neutral also. And that picture there is sulfur dioxide coming off a volcanic vent, so the smoke you see there is SO2. They can be neutralised by strong bases to form salts and water, so once again it's an acid-base reaction, just like for the metallic oxides. Some common acidic, non-metallic oxides include CO2, NO2, SO2, SO3, and P4O10. And I'll get into these in a bit more detail now. So here's an example, carbon dioxide gas reacting with potassium hydroxide, and what we get is potassium carbonate and water. So that's an acid-base reaction. So sulfur dioxide can react with water to form sulfurous acid, which can lead to acid rain. And that's what that picture there is. It's a forest in Northern Europe, and as you can see from the trees, it's been really quite devastated by acid rain. So sulfur dioxide reactions turning into acids are very bad for our environment. So here's the equation. SO2 gas reacting with water goes to sulfurous acid, and that's the formula there. Now, let's look at some properties of metal oxides and non-metal oxides. So this is a nice summary for you to take away. So let's look at the properties, and we look at metal oxides and non-metal oxides. So metal oxides, the bonding, it has strong ionic bonds which extend throughout the lattice. A non-metal oxide has strong covalent bonds, okay, because it's non-metal, that's the way they bond. So the intramolecular bonds are covalent, and it has weak intermolecular forces. And down here you can see the definitions of intra and inter. Intramolecular bonds are within the molecule itself. Intermolecular forces are between molecules. So if we think of water, for example, the intramolecular bonds will be within one molecule of water, and the intermolecular forces will be between different molecules of water. Okay, let's look at the state at room temperature. A metal oxide will be a solid, non-metal oxide will be a gas, such as sulfur dioxide, carbon dioxide. Melting point, boiling point. In a metal oxide it's high because it's a solid, and in a non-metal oxide it's low because it's a gas. So that's a good summary for you to remember. Now looking at neutral and amphoteric oxides. The neutral non-metallic oxides include carbon monoxide, nitrogen monoxide, and dinitrogen oxide. Some oxides are amphoteric, which means they display both acidic and basic characteristics. So they can act as both. And a good example of an amphoteric molecule is water. It can act as, even though it's neutral, it can act as acidic and basic. Okay, so they can be neutralised by either an acid or a base. Some common amphoteric oxides for you to remember include aluminium oxide, zinc oxide, lead oxide, and tin oxide. So some examples. Zinc oxide can act as an acid or a base because it's amphoteric. It depends on the pH. In acids, zinc oxide can react with an acid to form zinc ions and water. In bases, it'll react with hydroxide ions and water to produce zinc hydroxide. Another example, aluminium oxide with an acid will produce a compound that is bound to water molecules. And with a base, hydroxide ions, it will produce aluminium hydroxide. So as you can see, it can react either way. So now we'll look at some questions. Which of the following is not correct about metallic oxides? Now, the answer is metallic oxides do not dissolve in water at all. And I'll describe to you why that is. So some metallic oxides will actually dissolve in water. So therefore D is incorrect. And the other three options are correct. So they're not the answer. So metallic oxides are basic. Yes, that's true. They are ionic compounds. Yes, they are. And they react with acids to produce salt and water. Yes. So that's why the answer to this is D. Question 2. Which of the following is correct about acidic oxides? So we'll have a look at the answers that we have. And all non-metallic oxides are acidic or amphoteric. And some non-metallic oxides are neutral. So if we look at our options, the answer has to be A. Non-metallic oxides are acidic oxides. Okay? The other parts, acidic oxides react with acids. All non-metallic oxides are acidic. Acidic oxides are ionic substances. Those three options are incorrect. Question 3. Which of the following correctly explains amphoteric oxides? So we have a look at our options. Now going back to recap, amphoteric describes the ability of a compound to react with both acids and bases. So our answer is going to be amphoteric oxides can be neutralised by either an acid or a base. Okay, amphoteric oxides can react with water. That's not correct. Some will, some won't. Okay. Part C, they are metallic oxides. That's not true. And they are non-metallic oxides. That's not true either. So our answer is going to be part B. Question 4, we've got a table. Classify the following oxides as acidic, basic, amphoteric, or neutral. So from what I've run through, you should be able to think that they are one of these things and put a tick in the box. So let's look at zinc oxide. That's a metallic oxide. So it's actually going to be amphoteric. Okay? So even though it's a metallic oxide, it's one of the ones that's amphoteric that you need to remember. Another one to remember is lead oxide. That's also amphoteric. Nitrogen monoxide, non-metal. It's going to be a basic oxide. Sorry, an acidic oxide. Sulfur trioxide again, a non-metallic oxide. So it's going to be acidic. And finally, nickel oxide. Okay, it's a metallic oxide, so it's basic. Finally, question 5. Identify oxides which act as acids and describe the conditions under which they act as acids. So, oxides of nonmetals, just remember that the majority will be acidic oxides. For example, sulfur dioxide and carbon dioxide. And the conditions, they'll act as acids when they're dissolved in water, such as carbonated drinks. Carbon dioxide in drinks will make the drinks slightly acidic. So that wraps up the discussion about oxides and their characteristics. And next time I'll be discussing the periodic trends of oxides.